Okay, so in the second part, we classify numbers. Classify numbers. What is a classification of numbers? So it depends on the steps we understand or we know the numbers. The first step, we have 1, 2, 3, 4. They are called counting numbers or the natural numbers. Okay, so that's the first type of number we learned when we were baby. And here we use this ellipsis to indicate this will continue indefinitely. So it's not just a 1, 2, 3, 4. You will have 5, 6, 7, 8, 9, 10, 11, and even bigger number. Okay? Okay, so that's the first type of number we learned. After that, we learn another one is 0. So we join 0 to this discussion. 0 is not natural. It's a very abstract. What 0 means? 0 means nothing. It's very difficult to learn nothing when we were a kid. So they are called, including 0, they are called the whole numbers. So from counting number to whole number, we'll only add 0. From counting number to whole number, we just add this 0. And then we learn what is a negative number. I owe you $2, the negative 2. Okay, so the integer. Definition. The integers are the set of numbers. So this time is 2 and indefinite set. -3, -2, -1, sorry. 0, 1, 2, 3. Ellipses. Okay, so ellipses. Okay, I'm trying to write down this word to emphasize me. It's called ellipses. Okay, so this is a set of integers. To the left, to the negative part is indefinite. To the right part is also indefinite. Infinite. Okay? Okay, so that's a integer. After integer, we learn the rational numbers. So a rational number is a number that can be written as P over Q, where PQ are integers and the Q is not equal to 0. Okay, so rational number means it's a P over Q. Denominator is not 0. And the P is called the numerator. P is called the numerator. And Q is called the denominator. Sorry, called the denominator. The denominator. Okay, so if we want to represent the set of all rational numbers, write this way. or you use PQAB, whatever. Okay, so this is a set builder notation, whatever name it has. Set builder notation. You have element representative, and it satisfies certain condition. Okay. So this is a rational number. A rational number, in principle, represents the quotient, right? A over B means A is divided by B. For example, if you have 1 over, let's first start from simple one. 1 over 2 is actually equal to 1 divided by 2. Then it is equal to 0.5. This is a decimals. It's a decimals, 0.5, 0.10, and or maybe it's 2 over 5, it's 0.4, whatever. And sometimes if you are not lucky, it will be 0.3333 indefinitely, right? You have repeated numbers. All the rational numbers can be written as decimals with repeated part. Every number will be written like that. And sometimes some decimals, is indefinite, not repeated. Non-repeated. This one, remember, we had a way to represent it. It's they use bar. Okay, let's use bar. So 1 over 3 is 0.33 repeated. And some decimals, they are indefinite and non-repeated. This is indefinite, but it is repeated, so it's not the case we're talking about. And this indefinite non-repeated decimals are irrational numbers. They are called indefinite non-repeated decimal numbers are called irrational numbers. So decimals are slightly larger than the rational. For example, pi. Oops. 3.1415926 whatever. So this one is irrational. And square root of 2, it is irrational. Okay? So if we put rational and irrational numbers together, like if we put all decimal numbers together, decimal numbers, sometimes they're finite, they're definite, finite. Sometimes they are infinite but repeated. Sometimes they are infinite but not repeated. Put all them together, they are called the real numbers. The set of real numbers is the union of the set of rational numbers with the set of irrational numbers. Okay, so you put the rational, irrational together. That's it's called the real numbers. So in principle, you just say you put all decimal numbers together, it will be real numbers. Of course, decimal number is not just 0 point stuff. 1.2 is also a decimal number. Okay, 1.2 is also a decimal number. It can have a very large integer part. It can be positive or negative. Okay. Okay, so the set of all real numbers for a long time will be our universal set. So when we have a universal set for the numbers, we will consider it like the real numbers. This is our universal set. And then there's a cut. This part is irrational. This is rational. Okay? So part of it is irrational numbers. Part of it is rational numbers. Okay. So for example is clear. If we have a set -3, 4/3, 0.12, square root of 2, pi, 10, 2.151515 repeated, right this way. Then let's see, we have natural numbers. Natural number, 10. Only 10 is a natural number. Integers can be positive and negative, so we include -3. -3, 10 integers. Irrational numbers, rational numbers, -3, 4/3. -3 can be written as a -3/1. All the integers are rational numbers. All the integers are rational numbers. And 4/3, of course, is irrational. 0.12 naively is a 12/100, so it's also rational. Square root of 2, we learn it, it's irrational. Keep it in mind. Square root of 2 is irrational. Pi is irrational. 10, of course, 10. And 2.151515 repeated. It's indefinite but repeated, so this is also rational. Okay, and irrational, see, except rational, all other numbers are irrational. Square root of 2 and pi. Real numbers, you just list all of them. They are all real numbers. So that's why we say that's a universal set. All the numbers in your mind so far should be the real numbers. All the numbers are real numbers. Okay? Okay, so that's our classification. Well, we like -3. It's digits, very easy. We like 0.12. I know it stops. It's finite, right? It's easy to understand. Well, 4/3. If you compute 4/3 a little bit, it will be 1.33333 repeated. And square root of 2 is even difficult. 1.4, 1.4141 stuff. It's indefinite. And this 2.151515 is also indefinite. So if it's indefinite, we cannot handle it. Even we cannot finish writing. So there's a way to approximate. Approximation. Whenever you do approximation, they're your choice. They're choices. You may choose this approximation, you may choose that approximation. So there are two common ways to approximate some numbers. One is a truncation, not truncating. One is a truncation one is a rounding. One is truncation, one is rounding. Truncation just means you have this number. I say we truncate to 2 decimal places. This is decimal places. After two decimal places, we just cut them. I don't need it. That's all. Truncate with to 2 decimal place. Truncate to 2 decimal place. 2 decimal places. So I don't care what the rest of the digits, just cut. So it's a truncate. What is a rounding? Rounding has a following meaning. For example, if I have 2.159 stuff, if you truncate at 2 decimal place to 2 decimal places, 9 is extremely large. It's almost the 6. So I don't want to simply just remove 9 because it's so close to 2.6. So I round up. Add a 1 to the last decimal place. So that's a rounding. So what number is considered large? What number is considered small? 5, 6, 7, 8, 9, they are large. You are going to round up. 0, 1, 2, 3, 4, you will round off. Right? You will round off, just remove. So that's a rounding process. When you see the next decimal place is a 5, 6, 7, 8, 9, you will round up. You add 1 to the last digits. If you have 0, 1, 2, 3, 4 for the next decimal place, you will cut. So this is a rounding. We all know what it is. Okay? So for example, if we have this, it's a simple stuff, so we will just have something like this. So if we have rounded to 2 decimal places, so you see here it's a 3, 1, 4. Next is also 1. It's a 1. It's a small, so just cut it. And if you truncate it to 2 decimal places, it just means when you see the copy 2 decimal places, and enough, you don't even look at the next decimal place. This is truncate. Okay, but if, for example, if you round it, if the number is rounded to 4 decimal places, you will see 1, 2, 3, 4. So 3.141. 5, but the 5th decimal place is 9, it's too big, so you just round up, so it's 6. You have to change 5 to be 6. But if you truncate it, if the number is truncated to 4 decimal places, you will just simply copy 4 decimal places, and that's enough. You don't even look at the next digits. So that's a truncation and the rounding. Okay, so next, you're having the calculator. we do not allow calculate in the exam, so we do not discuss any calculate in the exam, calculate in the lecture. So in the exam, you are not supposed to use any calculator to compute anything. Okay? So in the exam, don't write decimal number. Write all the numbers as a rational number. Don't give me the approximation. If you want to write 2 pi, it's 2 pi. It's not 6.28. Okay? So in the exam, 2 pi is not equal to 6.28. Just be careful. Don't use approximation to write your answer. 2 pi is 2 pi. Square root of 2 is square root of 2. If I see 1.4142, it means you use calculator because no one will memorize those numbers correctly in several decimal places. Okay, so don't use approximation. We introduce approximation just as a method, but you should not leave any approximation as your final answer in the exam. That's not allowed. Okay, so always write this. And also 4.3 is not equal to 1.33. They are not equal. The right side are always approximation. Approximation are not allowed for the final answer unless I ask you to do the approximation. If I don't do that, then you should never leave decimal numbers as your final answer. Write it as a rational number. Okay? Okay, cool. So that's all for the first lecture. If you have any questions, send me an email. Thank you very much.